Today's program is prime atom number, palindrome number, prime palindrome number, Emirp number, all four programs side by side, all four concepts side by side. So these are all the concepts of this are the palindrome and palindrome prime number. This is Emirp number. This is prime atom number. So we'll go through each and every of one of those and also their programs. So hi, I'm CJ, welcome to Education Valley. Today we have another amazing video on the Java program, so let's do it. So first of all, let's start with prime number. So prime number or palindrome number is the reverse of the number is equals to number. Example is 121. Prime palindrome number is a reverse of the number is equal to number, and also the number is prime. Emirp number is prime and the reverse of the number is also prime. So here you see side by side, then I will show you the inside. So side by side, this is just prime number. Both the number is prime and the reverse of the number is also prime. Here the reverse of the number is equal to the number. When you will reverse that number, example 121, 131, etc, etc, this is the reverse of the number is equals to number. It will plus, if that number is also prime number, then it is a prime palindrome number. Palindrome number is a number, reverse of the number is equal to number. Prime atom number is different from all of those. Reverse of square of the number, reverse of square of the number is equals to square of reverse of that number. So these are all four concepts. Let's dive into each one of those. So start with palindrome. So palindrome's short form is Palin, palindrome. So that's what Palin number is, prime palindrome number. Then there is prime palindrome, which is just palindrome numbers which are also prime numbers. These are the examples: 121, 202, 12321. Prime palindrome numbers are 11, 131, 10321 because both of those are same. After that we come to, let's go through program of all of those as well. So this is the program for Palin number or palindrome number. Okay, so what we do is just reverse the number and then check whether reverse of the number is equal to number or not. So to learn reversing of the number, matref. Okay, so here we reverse the number. So in example we are taking 2695. How we reverse the number is that we use 10, and to get the last digit we use 10 modulus, and to separate the last digit and get the rest of the numbers we use divide 10. So basically you can see all four cases, like what one number is completely converted to the reverse of that number. So what we do is we keep dividing the number each time and remove one digit from the last, and those digit we can capture by using modulus. So we take a variable and create space by multiplying that variable. So here it is. So we can create space by multiplying that variable into 10 and then adding the modulus into it. So in this example we are continuously dividing the number each times to remove the last digit, and the last digit we are capturing by using modulus and then adding it by creating a space in the existing number and summing up all of those together. So as you can see in this conversion, 0 into 10 plus mod 10, which is 0 plus 5, then we do 50 plus 9, 590, which is like last we had 59, which is converted into 10, 590. Then we got the modulus of the remaining number, which is 596. Then we multiply again with 10 and then create space for adding 2, so 5692. That's how we convert that's how we reverse a number. So once we have reversed the number, for prime palindrome we need to check prime. So to check prime, it is very easy. So prime number is a number which is only divisible by 1 and the number itself, aka that is it is not divisible by 2, starting with 2 to n minus 1. So by divisible we mean that it does not leaves a remainder of 0. Only 2 times if it leaves a remainder of 0, that is in case of 1 and the number itself. So what we can do is run the loop from 2 to n minus 1. If all the remainders are 0, it is a prime number, otherwise it is not a prime number. Simple. So what we do is run a loop from 2 to n minus 1. If all the numbers are not equal to 0, it is a prime number. If any of those is equals to 0, if any of those was equals to 0, 17 would not have been a prime number. 17 only has only is completely divisible by 1 and 17, as you can see right here. So any number which is prime as well as not divisible by any other number except 1 and that number, that is prime number. So we run a loop from 2 to I minus 1, like less than 1, like less than I. So if modulus is equals to 0, we increase c plus plus. If c is equals to 0, that means c is equals to 0 from 2 to n minus 1. So that means it is a prime number. If it is a prime number, we reverse the number using what we did here. We reverse the number using the modulus and division and multiplying to create a space to add that number. We do that here, and z into 10 plus 0. Okay, perfect. We do that to add that number, and then we check if that number is a prime palindrome number or not. If it is, we print it, otherwise we don't. Also, we keep a count in this program. It's of course in the description below. Next, let's go to Emirp number. So Emirp number is a number which is prime, and the reverse of the number is also prime. Number is prime, reverse of the number is prime. So basically you check both of the number is prime or not. We create a is prime. Okay, so we create a method to check prime or not, and then we pass both of the number to is prime, and if both are 1 means true here. So if both of those are prime, we output it is an Emirp number, otherwise it is not. Also, we are sending in 3 numbers instead of only 2. So we are sending the reverse of the number, which we reversed by using what I showed you, like reversing the number. I show you again. We using modulus to get the remainder, and then creating space in that variable and adding that modulus to that number. So that's how we reverse the number. After that, we send 3 numbers. So first is the number, the second is 2, and the third is C. C is used to keep count of how many numbers were prime or not, were factorial or not. 2 starts from, like, every division will start from 2 and will end to n minus 1. That's why we have to make 2 again, because otherwise it will be n minus 1 after the first iteration or recursion is done. So we make it 2 again, and we make 0 again, because if the previous number had any count of, like, we can omit 2 as well and it will still work, but we should theoretically pass 0 as well. If it is the number of factorials of that number is same, then that's why we make the counter 0 again. So if f is less than x, This is like recursion because we are calling the method again and again for to do the work. F increases, like f is 2, which is dividing. If is equals to 0, f is less than x, like emirp f is less than x, it will continue till f is less than x. Okay, so f, same, we are using modulus and then checking it again and again. If c is equals to 0, we return 1, which is true. We could have also returned 0 and checked here 0, but we are returning as true or false, or we could have directly returned it. So this is using recursion. We are checking if it is a prime number or not. Here we are using iteration to check whether it is a prime number or not. Both are same. It recurs from 2 to I minus 1. This recurs from 2 to I minus 1, and yeah, it keeps the count, and if count is 0, it is a prime number, otherwise it is not a prime number. So we did emirp number, we reverse the number and check if it is a prime number or not. These two are the code. You can use anyone. This is iteration and this is recursion. Okay, so perfect. Now what we have left is we did palindrome number or Palin number, reverse of the number is equals to number, prime palindrome number, reverse of the number equal to number, plus it is also a prime. emirp number is prime and the reverse of the number is also prime. Last is the prime Adam number. Prime Adam number is 13, 311, 2011, etc, etc. Like you square the number and then reverse that square, keep it in a variable, then reverse that number and square it. If both of those are equal, it is a prime Adam number, otherwise it is not. This is also a relatively very simple program. So first we check if it is a prime number or not. Prime Adam, it is like it also has to be a prime. Everyone wants prime. Optimus Prime, the prime age. Okay, so first we check it is a prime number or not, otherwise then we check it is a Adam number or not. Adam number is square of the number is equals to number, and then the reverse of the number is equal to square. Okay, so we reverse that number, then we square that number, reverse into reverse. Here we will have we reverse that number is equals to reverse, we reverse that number. Okay, perfect. Then we squared that number. Here we have 916 right now. Then we squared of the number, then we squared 13 into 13, 169, and then we have to find the reverse that square. Then we reverse that square using how we reverse the number, using create space by multiplying by 10 and then modulus to remainder until it comes to 0. Until it comes to 0 as a divide, until it comes to 0, until the quotient, like what divisor, this is quotient, until quotient comes to 0 we keep on dividing until quotient comes to 0, until it is like not 0, like greater than 0, we keep on dividing, and that's how we reverse that number. If both of those are equal, then we have a prime Adam number. Simple. We keep also in this, we keep a count of the number of prime Adam numbers in that range. I think we are taking a range here. Okay, so let's I hope you understood all of the programs. The prime Adam number, it is a prime number and then reverse of the square of the number. reverse of square of the number, reverse of the square of the number is equals to square of the reverse of that number. Okay, perfect. Palindrome. Let's run all these programs. S control V, control V, control S, control V. Okay, so it is the Palin number. Enter a number. Palin number example is 121. Palin number. It is not a palindrome number. Interesting. Let's check prime palindrome number. Emirp upper limit range, lower limit 1, upper limit 1000. So prime palindrome numbers in range are 1 to 100 or 1 2 3 5 7 11. Frequency of such number is 6. So in the previous one maybe there is an error. Prime palindrome, how we check the palindrome number. So if palindrome number palindrome number let's check AMRP number. AMRP number is, enter a number. AMRP number, it is 17, is an AMRP number. Perfect. Prime Adam number, let's check prime Adam number is 13. 1 and 1000. 1 2 3 13 31. No, 13 is there, so it is prime number and these are the frequencies of that number. So let's check Palin again. What's the issue that's coming? So run Palin again, enter a number which is definitely Palin, not a palindrome number. Great. 11, it is not a palindrome number. 1. Okay, so it was a printing issue. There is no issue in this program, only that we are printing it wrong. It is not a palindrome number. Not a palindrome number. 121. It is a palindrome number. Great. So this was a program all together, one shot. Thank you.